Okay, this week we're gonna focus on OSI model. That's important. I think a big chunk of network plus certification will be addressing OSI and protocols. I know that the acronyms and the terminology will be new for most of you. However, right, as you go through the course, we're gonna repeat some of the same information, and you will see that throughout your program as well. So we're gonna be more familiar with the protocols. I would encourage you to start reading through them and kind of, memorize them as you go through the course. That's gonna help you prepare for your certification down the line. Network Plus, like I mentioned, is a little harder than Security Plus certification, but you can pass. I've had many students that pass the certification after or at the end of the course. So this week, we're gonna talk about protocols and OSI, like I mentioned. At the end of the session, maybe I'm gonna reserve a little bit more than an hour to have you make your own cables. We're gonna, if you want, you can start with a straight through, which is your normal Ethernet cable at the end. Or if you want to do a crossover cable, so they're slightly different standard. One end is different than the other. That way you can connect your PC with your laptop or your desktop with your laptop, etc. And then if time permits, I did buy you some new compression tools from Amazon, and that way you can use it to do compression for your RG6, which is your coax or your thicknet. I posted some of the YouTube videos, and I hope that you had some time to kind of look through it real quick. That kind of give you a perspective of what you're going to be doing, but we'll talk about that at the end of the session or the last hour. Okay. So we're going to go over the assignments as we look through the notes. At the beginning of the notes, it talks about protocol, and protocol is really defined as a set of rules, right? We talked about this last week to really how the system process data. You are going to have different protocols that's associated with different services. And in IT and cybersecurity, this is really important. Everything is tied to a service, for example, like web service, or some kind of file transfer service. This is where you're going to see how data is accessed and processed. And then the system needs to have a standardized way to really understand what kind of service it's working with. So it gives you the definition at the beginning, but you have to know that there are two categories of protocol. One is going to be routable. We talked about the router as a system that would bring your traffic into your network and leaving your network, right? So it's like a transit system. And the non-routable protocols, basically that is not going to be able to cross the router. That's used internally. On the system itself, right, or within the network, it's not able to pass the router. So you're going to have two of those categories. Now, NetBEUI or NetBIOS extended user interface is an older protocol, what we call them. This is a legacy protocol. This was primarily made for the older system like Windows or DOS. So why are we still learning it today? Because when you're installing Windows, right, NetBEUI is used to still today, right, in the back as a way to determine the host name, okay? Before, when we didn't have a way to set up a TCP IP network, all the systems were communicated by identifying each system as names, right, host names. Nowadays, we see systems as connected through IP, using IP address as a connectionless, but with TCP. So what you see is NetBEUI, right? Likely that's going to be on your quiz and final, and also some certification like Network Plus. You would see that it's still being integrated in your current Windows 10 and 11 because it was supported in 7. So as you go through and set up system, like your client system, your Windows system to be communicated, you are gonna see that there's an option right in the back. So this is how it's able to see your system information across the network. Okay, so let's go through and answer some questions. So the first question, it says, what are the network protocols? We saw the definition on the first page. And how are network protocols used to establish system communication? One, network protocols are rules for formatting and processing data, right? Whether it's web data, where it has to be able to give you the content, what you see on screen with HTML, or it could be other type of service. So for example, daylight saving, you would have to change your time, right? Like either we roll back in the fall or we roll forward an hour. And for our network system, we use a protocol to be able to synchronize the data. So when you wake up in the morning and you look at your smartphone, your new time is already updated through the mobile network, right? So it uses a protocol to be able to update the time from the server itself, right? So that way the user doesn't have to change the time. And the use of protocols that allows them to communicate, your system communicate with each other, regardless of the operating system of use. So I can have a network that has Apple systems along with Windows system. I can have Android mixed with PC, right, with Windows system. So regardless of the software and the hardware you use, you would see that these protocols are standardized so we can have a mix, a variety, a diverse group of systems inside the network. Because when you enter the field, you're going to see that a lot of the companies, they're going to use a mix of things, just like how you are at home, right? Sometimes bring your own devices to work. Sometimes they provide you with the system to use. But you're going to have a mix of different systems, and the protocols allow us to establish the communication across different types of systems, regardless of its hardware or software. Then in the second question, you can see this also on page 1. We talk about NetBEUI, Net B-E-U-I, and it is a way that we can efficiently and simplify, right, how it would route the data to the system. And from the system. And the advantageous is simply we can configure and allow this protocol to work, right? So by default, this is in the back, so you would see NetBIOS is being used for system identification with system name. So when you install Windows, right, you can use the default name that it comes with, or you can reset your name. And this is how the system is able to distinguish one system from another, is either by name or by address. So NetBEUI allows you to configure and simplify the process and how it's able to bring, right, data from that system outside to the external networks and from inside. But we streamline this process now with other protocols, right? But it is one of the legacy protocol that's still with us today. In security, when you're using legacy protocol, you have to understand the risk behind it. So we know that there's risk in using Windows system always, right? So knowing that, we know that it is there, it is available, we have to be mindful of it so that way we have appropriate control for it. Okay, so I'm gonna talk a little bit more about number 3, as we talked about NetBIOS and NetBEUI. So there are 2 modes for this particular protocol. One is going to be what's called a session mode, and 2 is going to be a datagram mode. Now, session is used when it is for connection or connection oriented. That means that it needs to be able to send signal from that system to another system, right? Physical connection is established along with a logical connection through the protocol. So when we say physical connection, that means that we have to have a media some form to be able to have the system communicate, right? Via like a cable. Logical system is that it needs to recognize one another, right? At the higher level, at the OS level. So this is a way that it can establish communication, right, through the session mode. And in the case that if there's transmission error, it would then retransmit. Because if we don't do this, we are not going to be able to have successful communication from one system to another. So a session mode needs to be enabled or configured, right, using that protocol for communication purposes. The datagram mode is connectionless. This is when you don't need the session mode, okay? And so it is not supporting data error detection. So in the case that if you're using the datagram mode, it doesn't retransmit in the case there's error, right? So for example, I have two systems, right? One system might be down. And if I'm using the second mode, the datagram mode, what happens is if I don't transmit data successfully from system A to system B, it doesn't matter, right? It doesn't detect that and it doesn't retransmit. So normally in a network that we want to make sure there's successful routable information, we would then defer to the session mode if we're using net viewing, okay? Any question? Okay, so you can read a little bit more about this in the notes itself, and then you can also go back and watch the video. And it talks about that here, right? It's able to look at, so when you say a MAC address, that's different than an IP address. Some of you know this, right? That stands for Media Access Controller Address. All of the MAC address is ingrained or programmed onto your network adapter, meaning your network interface card or your wireless adapter. Every vendor that sells, right, network adapters, they are given a set of MAC addresses to perform. Now, in security, we look at MAC addresses, how we can pinpoint the physical system, right? Which system is talking? Because the IP address, as you know, MAC and IP can be spoofed using certain software tools. But the MAC address, we can identify, right, which system on what segment of the network. And the switch mainly use the MAC address to determine, right, whether it needs to be able to transmit or transfer that information across the network. So the MAC address is mentioned here, and it talks about how it would be able to determine which system is sending, right, and from what network. And then for NetBIOS, so you would see that these protocols kind of fall into two categories, right? Either they are TCP or they're UDP, right? Transmission Control Protocol or User Datagram Protocol. I think I talked briefly about User Datagram Protocol last week, where those are like, you know, how when you're receiving package, they just leave it at your door, right? They don't care whether you get it or not, right? There's no confirmation, and you often see UDP when you're playing, like when you're streaming video or audio, like iHeartRadio, or when you're playing YouTube video. It would opens as it arrives, right? Now TCP is different. TCP makes sure that there's reliability involved. So all your data is broken into multiple packets. So for example, I want to download a movie, right? My movie is maybe 2 megabytes, okay? That megabytes is then broken into many packets. So think of it like how you need to ship a very large shipment, and we need to box it into smaller boxes, send, okay? Now TCP it's going to take everything and once it's received and then reassemble it in its entirety before it gives it to you. So in order for me to watch the movie after I download, the entire size, the full file needs to be then received after I download. Okay, but when you're streaming online, your movie, let's say you're watching a movie via YouTube, it's going to again broken up into many packets. But what happens with UDP is it's just going to open, for example, like maybe parts of the movie might arrive before the beginning credits, right? So it's going to wait for the beginning credits. So it's going to open as it arrives. Okay. TCP, make sure that there's reliability. So NetBIOS falls into these two categories. You can use them in both. Now, the port range that it uses between 137 to 139. So in security, a lot of times we scan system and look at what ports is being used. Those are like doors and windows that the system used for communication, right? We would see if it shows up as this port number, then you know that it is NetBIOS. That's legacy protocol. Okay. All right. So older technology, right? It talks about the mode here on the end of page 1 and going into page 2. And I touch a little bit on TCP, make sure we understand, right, what that is. So TCP makes your systems receive things in its entirety. Like I said, if I need to ship a bike, right, I would take the handle, put it in the box. I would take a wheel, put it in a box. TCP, make sure that you receive all the packages, reassemble the bike to the way it's supposed to be, and present to you a bike, right? Where UDP is gonna give you, oh, here's the pedal, here's the handle. The wheel might come like 2 seconds later, right? Or microseconds later, etc. Okay, so TCP is also an older technology, but is now integrated in all networks. And IP is mostly used for addressing. Okay. Okay. So for 4, it says the internet is built upon what protocol suite? Describe its capability. And if you look at all the IT jobs, right, especially related to networking, you would see that it requires you to know how to manage a TCP IP network, okay? Meaning that we need to understand what this protocol is used for. And when you're accessing website, HTTP falls under TCP, right? And IP address is mostly used for delivery purposes, routing, right? It's able to get the information from one network to the next network via addressing. And TCP IP's job is that, to make sure that communication can be established across all types of operating systems. So it is robust, right? And it's used for different type of OSs. So if you're using Android, right, you're still part of the TCP IP networks as you are connected to your service provider. Or if you're using iOS, same thing. And it's really designed to reroute packets. So in the case that if I need to send, like I give you an example, my bicycle from my home to my friend's house, right? TCP makes sure that all my packets arrive to the destination successfully. If it doesn't, right, it needs to reroute that. So in the case that, and then sometimes you can see that if the system timeout, so let's say that you're trying to go to a website and it's not responding, right? You get a 404 error, but it tells you the error, right? And it's going to prompt you, do you want to try to reload or reconnect? So it is a way to reestablish the communication so that way you can get the content that you need on your web browser, which is an application. Okay, any question? So make sure we know the difference between TCP and UDP, right? reliability versus unreliability. But why do we use that for streaming media, right? Is that important? Well, it's important, but if we compare the priority in that, right? The user would wait a little bit for, the music to stream or the video to stream. However, it is faster if you're using UDP, right? You will get your packets, your data quicker. This is why we use streaming. We use it for streaming. Okay, 5. The difference between routable and non-routable protocols, and you saw this at the beginning, right? A routable protocol, the packets leave the network, pass through the router, right? It goes through the router, and the router is going to bring it from network A to network B. If I leave RCCE network, right, the router is going to take my traffic from Riverside Community College District, and it's going to send it to the service provider. That's how we're able to connect, right? And that service provider is going to then send it to the next network. And when you do trace route command, which we'll talk about the command later, you would see, right, where your packets go from point A to point B. You will follow it. And so it sends it to the router, and then the router would then send it to the destination network. And that's how we're able to establish communication. Now, the non-routable protocol, it doesn't go to the router, right? It doesn't cross the router, okay? That means that it simply is a way that we communicate within. So, can we have a router within a network? Sure, okay? So, for example, I want to make sure that one part of my network is private, right? Like for my financial system in the bank. I would be able to set it up where it treats it as a separate network and forcing it through a router or a layer 4 switch. Some networks you will see that their voice over IP or their call center is a separate network. They will use a higher layer switch that's also routable. It's able to route packets. Now, we want to be able to distinguish between these two because basically it's for functionality and use of our systems. Any question? Okay. So one important thing about this particular industry in IT and cybersecurity, I know some of you are going for the IT certificate and some of you are going for the cybersecurity certificate. You have to understand protocols and you have to know the associated port number to the protocol. It's kind of like, how when you use Google Maps, right? Driving from home to school, it tells you the exit number, let's say 56, right? Google Map, the mapping system, it sees exit number and then it gives you the name. The name is actually just for human context, the text that we see, right? The system computer only sees numerical value. Understand that. So what happens is we use addressing, we use port value to really represent services and functionality of the services, okay? So when you're scanning system for attacks and things like that, you're gonna see the services associated with the port value. So we're gonna go over that next. And that's important to kind of memorize because then you're gonna see, okay, this service is used in this particular network and it could be a risky service, right? Or a certain service is secure. So all right. So it talks about routable and non-routable protocol. And I kind of wanted to talk a little bit about Telnet. Telnet been around since the 70s. Many of you were not born then. Your parents probably were born then or even before your parents' era. Telnet is something that we disable in the network only because you can remotely connect to a system and that system is transparent. There's no protection whatsoever. Okay. Back in the day, technical people would use Telnet to connect system to another. It's a way that we can use a terminal, meaning that I would establish a communication using some kind of command line or a terminal through Telnet service. So if in security, if you see Telnet port 23 is enabled, you should disable it. Because this is a way an attacker can come into your network and connect to that particular system that's enabled. Okay. So it's a way that you can access the shell or of that system. Okay. Then we have file transfer protocol. This is a not secure protocol. It's FTP. This is used commonly for things like file servers, public file servers. So Mozilla has one. This is a way that people publicly share back in the day, right? Making a news article or even files. So you see that it uses port 20 and 21. Now compare that to SFTP. So this came later. The industry said, well, we have to find a better way to connect to system and download and upload and share files. So they established what's called secure file transfer protocol, which uses SSH in the back. That's port 22. So if you see port 20 and 21, right, that's for FTP, file transfer protocol. And in my ethical hacking class, the first couple of weeks, or they actually scan system for and looking for FTP. Now you can grab banners like servers and be able to see. So if it uses FTP, there's a way to attack with FTP, right? So every service has some flaw. There's no service that's not flawed. This is why the industry demands security people. However, right, you need to be mindful of that. So you will implement solutions to support that service securely. Okay, so SFTP is next. So let's go through and answer the next question so you have a clearer picture. So we talked about FTP. So for A, so number 6 asks you to provide the protocol and the port number for the following scenario. You often see something like this on the certification, on our quiz or exam. So file transferring protocol between the two computers using IP network, so TCP IP, but it is not encrypted. That means that there's no security implementation, no algorithm that changes the data format into non-readable data. Right? This is known as FTP. And FTP uses port 20 and 21. So if I want to set up an FTP server, I can, right? And let's say I want to make an FTP server so I can share files with you, right? So I would configure the system. It's basically a package that you install and enable the service. During that process, it's going to turn on this port value. And using that port, that's like the door and window for that, my system, my server, to be able to distribute file to your system through the network. And for your system to connect, now, we use authentication process, but back in the day, you can log in as anonymous and be able to do that. Some server, if you look online, FTP servers are still around, right? I know Mozilla has one. There are quite a few public servers that offer that. So with that, it needs to be able to enable specific port. Now, do I have to use these ports? No, right? Administrator can specify the port that they use in the configuration process. So if you're using non-common port, this is common ports, then you just need to make sure that it's configured properly for your system. All right. So for email delivery, for your email server, you would see Simple Mail Transfer Protocol, SMTP. Now, this is different than POP3 or, other email based, but SMTP uses port 25. So when you're looking at like your email on Outlook, the server that is, delivering the email to your inbox, it uses SMTP. Question? Okay, let me move 6 down to, is that okay? Or we're still recording 5? So I'll put 6 on the next page so we can go over the next one. You can find this information on page 2 of your notes for the routable and non-routable. Okay, so going a little bit more into the mail server. So when using web mail servers, like Outlook.com, like Gmail, right? Traditionally, you would see the client system that connects to the webmail servers, it would use POP3 or Post Office Protocol version 3. And it uses port number 110. Now, for my students that are doing forensic and all of these things, you're gonna see relevant in like ethical hacking, forensic, right? Security classes, because we go over this again because it ties to services. So in forensic, when we do email forensic, we look at like which server handles your email. Where did that email come from? So let's say I'm trying to find out where did that phishing email originate, right? Because my user had clicked on the phishing email. So when you do the forensic, it's going to tell you all the servers that handles that email from the time where it's sent, possibly somewhere in the world, right? And then be able to track it all the way to your network. And we would see, right, these protocols being integrated. If it's webmail, you're gonna see POP3. If it's internet message access protocol, your IMAP, this is a way that you can download or search your mail. Okay, so I do that all the time because, and a lot of the students tell me, oh, your message box on Canvas is huge. I don't delete my mail because in the case I need to go back and find something, I can. So it's a way that we can quickly search through our mail, possibly by subject, by content, by header information. And it uses the headers, the email headers, to be able to track, right, what mail you receive in your inbox. So on the client system, so the C and D, the POP3 and the IMAP, it's for your computer, the system that's connecting to the server, right? But the SMTP is for the server itself, so that's the difference. And IMAP uses port 143. RDP, this is only for Windows environment. So if you're using TeamViewer, if you're using, so in the past, like I demonstrate on how you can bring up an instance on cloud like AWS or Azure, and you can remotely connect to it, right? This is how a lot of administrators connect to their cloud systems. And on Windows system, right, you can search on your Windows bar, if you put in RDP, it's gonna tell you that you can remotely connect using RDP. This is a way that we can connect from one system to another, right, to its desktop. So if I want to connect my laptop, right, to a system at home, right, I would need to be able to connect to that network first and then use RDP and the public IP address for my system to connect. So, and it uses the common port number for this is 3389. Okay, now if you want to do secure data transfer for web, this is what you use with HTTPS, right? So for example, I log on to my bank website and I authenticate by using my username and password. It established a session, okay? A secure session where your data now becomes encrypted. So when I'm checking my balance, or let's say that I am looking to pay my bill, right? In the back for HTTPS, it couples, right? Most of the time now they're using TLS for the security part. So the transport layer of security, its job is to make sure it protects your information and your data while you're on HTTPS. Okay, we use it more than just HTTPS, but commonly you would see it for that. Or you would see secure socket layer SSL, right? The newer version, because the older version 1 or 2 had flaws, right? Heartbleed, and that was long ago. They fixed that. So that means that but you're like, wait a minute, right? HTTPS is port 443. Well, when you're using HTTPS, it pulls in this protocol to make sure that your session is securely communicated. Now, the way that in security, the attacker, what they can do is they can strip, right, your security. So if I want to do, like, if I want to make sure that I obtain your bank account information, I have to make sure that I can read your information, right? But this protects your information while you're on your account. So what they do is they use a tool to strip SSL, right? To break that algorithm and convert everything to plain text. So that way they can see what you see. Okay. So in some form of attacks, you're gonna see a lot of the web attacks, web-based. If it's client focused, you're gonna see that. Okay. Okay. Now, if you construct and deconstruct multimedia communication session, such as voice, video calls, video conferencing, streaming multimedia distribution, instant messaging online, over the internet, right? This uses SIP, SIP. Things like for Zoom, Teams, or even streaming. If you are doing instant messaging in like a game, like you're playing a game and you're able to chat at the same time, often it would refer to session initiation protocol, and it uses TCP or UDP. TCP, it uses 5061, and UDP it uses 5060. Now, in a network, when we turn off the service, we turn off that port, we close that window. Okay, when you close that window, it cannot communicate, right? Like, in order for you to go and come and go in your house, you have to go through the doors, right? So if we close that door, that specific number door, that exit, there's no way that the system will communicate. So when we configure security for a network, we would configure like the firewall for certain port. Let's say that I don't want any kind of streaming in my network. I will block, so I would make sure that these ports, any communication with these ports are not allowed. So when it sees it, it's going to kick it off, right? So on the access control list, on the rules, I would say that anything for 5060 or 5061, block it, stop it, right? Then it won't establish the communication. So that's one way that you can see from security compliance with the network defense. And then your poll, right? Last week, I think we talked about NIS for your network information service. It's the way that we can streamline a lot of like the maintenance, the management for the network. But you have to be able to see like which system on your network communicated, right? It's simple if you only have 20 computers or devices. But in a larger enterprise, when you look at the infrastructure, you might have 200,000 systems, right? Globally, some companies, like if you're looking at like Walmart, they're global, right? They have corporate office who there are workers using computers, and then you got sales terminal, you got all of these branches and stores, right? You got distribution warehouses. So what you see is you need to make sure that you see your devices, right? And we do this for streamlined purposes. So for example, I want to push updates to all my Windows PC. So that means that I need to see who's connected, which Windows PCs are connected, right? So a way that we can pull the devices across the network, we would use what's called SNMP, right? So in my Python for Network class, when I taught that a while back, right? We can write a script for SNMP. We can check all the servers that are connected. And you can do this so that way it's convenient, it's automated, right? And then we would be able to look at, right, which servers that would need to have updates, or we can automatically install updates through the script itself. And it doesn't take very long. But if you do it manually, you gotta go to check each one. You don't have time to check 200,000 systems, right? You are gonna use a service to see who's on, who's connected, which system, right? So it does an inventory for you, and it uses UDP 161. All right, I talked about network time previously, right? Daylight saving. Now, in an infrastructure, in a network, right? It's more than daylight saving. This is important for synchronization. You guys know that when, if you go to the ATM and you withdraw money, like right now, right? Let's say I take out $20 from the bank account. You notice that it shows pending, right? So they don't process your transaction until later on. Normally, they do a batch job. So all your transaction is going to be sent as a job, a batch, and database synchronizes. So if I withdraw my money here, right, in Moreno Valley, and an hour later I go to Orange County and I withdraw my money, it still keeps my record, right? Because the system synchronized across their networks. So a way that we make sure that it's synchronized is it needs to have time that is appropriate, right? In Windows network, if you are off by a certain allowable time, you cannot synchronize. So for example, I hire a new employee, I create that user account at my corporate office, okay? I set up that user account, and this person maybe works in New York. An hour later, this person shows up at work, they would be able to log into their account, because now my corporate server is syncing with their local server, so that way it will push their security information, their permissions, their privileges, okay? By default, Windows network, there's about, there's 60-minute span that you need, right? But who's gonna wait an hour for it to synchronize, okay? So in that, you gotta make sure that your systems, your time, there's not a huge variance, even though you're in different region, right? Because all your systems should be seeing each other as universal time, okay? So when we do that, we gotta make sure that our system is synchronizing appropriate time. If there's gap, you're gonna have some problem. Question? Okay. Last, server that assigns IP address to computer and devices on the network. And you see this with your home router. It has this, so you can go and check. It's called Dynamic Host Control Protocol. You will configure a server in this class for that. What it does is if a system boots on, right, it's gonna give an IP address from the pool. We can set up a pool of IP addresses to give. So when you turn on the computer here, right, when you look at the IP address, it will say 10 dot blah, 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 right? So there, the RCCD DHCP server gives you an IP address from the network, okay? And it's a lease, so it would be like for 60 days, 30 days, we can configure it. And it uses port UDP 67 or 68. Any question? Okay, like I said, try to remember the port number with the associated protocol and what it's used for. Okay, so there are more specifically like we talked about SFTP, but if you're familiar with port number, it also uses port 22, which is used for secure shell. Remember what I said about telnet? Telnet is not secure. We don't want to use that, right? A way that we can use secure communication between systems, like my computer with a switch, is we would use port 22 or SSH. If you ever use your Raspberry Pi, right, you connect to your Raspberry Pi, you can connect with SSH. You can remotely connect to another system like a Linux server with also SSH. Okay, SSH is also in Windows, so it's all the operating system support SSH. Okay, so look through this, and I know that might be a lot. I didn't talk about RTP, but you can see that it talks about real-time transport protocol. This is for audio and video over the internet. Also, right, along with your SIP, which is used for voice over IP. And then additional like media gateway control protocol for session management and multimedia conference. So you see a lot more of this now being integrated because post-COVID, right? After COVID, we had remotely worked and now we have to accommodate. So at the time of COVID, a lot of the network, they struggle because some of the services were not, right? Like if they don't have workers that work remotely, then you have to adapt remote access servers for the employees. Okay. Port 80. So I did a lab where my student looked at malware that was coming through the network. Some of you took my forensic class, right? So if you don't use HTTPS, if you use HTTP, its port is 80, right? 880. And this is, I think now the majority of all the websites that are required to go HTTPS, you do see a few of them have just HTTP. We don't recommend using HTTP for your domain, only because it's not secure, right? Like if you authenticate to your HTTP server as a user account, it's transparent. You don't have encryption to protect your data. So we want to make sure that the data is protected. And then your HTTPS use is 443 or 444. You do see some administrator set it up with 44. Okay. Now we're going to come back to this a little bit later on, right? Lightweight directory access protocol. When we set up Active Directory and things in Microsoft Server for your user to create subjects and objects in the directory for accounts and things like that. So, okay. One of the things I want to mention before we go to the next topic is DNS. I know some of you know this, right? So domain name service, I talked about this before. All the web server needs to connect to the DNS so you can have a website, right? You know how you can say, oh, I want to build a website. Well, you got to register for a domain, right? Basically, you register for a domain name service, right? Which is hosted at a server that someone is maintaining, like GoDaddy, AWS, Azure, and you pay for that. It has a public IP address, so that way it ties to the name, right? Like let's say mywebsite.com. That name is tied to an IP address using this service, okay? The name is for human, okay? You don't go around and say, visit my website. It's at 14.8.6.2, right? Nobody's going to remember that. Imagine if you give that to people, say, this is my website, right? No one remembers that. So when we build the internet, we say, okay, we have to find a way to associate the public domain address to the name. Mywebsite.com is to 14.2.6.11, right? Like google.com is 8.8.8.8, right? They have many addresses, but that's one of theirs. So now in the world association, there's an association that manages a list of all the domains and its associated IP addresses, right? So if you go GoDaddy, they have a range of IP addresses that are allowed to use. And they're gonna present to you, okay, you want mywebsite.com, mywebsite.net, well, mywebsite.co, etc. And as you go down the tier, it's cheaper because if the name is not common, right, you would pay less, but ultimately it's tied to an IP address. So it's a way that we put a name to a number, just like how you have a name to your social security, right? The government has that list. So the association has a list of the DNS, and this server job is to make sure it correlates that IP address to a name. And internally, we can also do this privately. It doesn't have to be public, but okay. So it talks about that here. And then we talked about DHCP. Any question? Okay. We'll come back to DNS. And if you take my 27, right, we talked about poisoning and all of that. So some of you knew. So your .com is part of FQDN. That stands for frequently, right, identified domain name. So it's basically common for human contacts. Okay, now let's talk about OSI layer. So before we get into each of the layer, you can go down to the next section of your notes, which starts on page 6, going into page 7, mostly start page 7. Okay, so when you're making cable today, that's for layer 1. Physical connection, where signal goes from the wire to the wire, okay? So when you turn on your computer, you know how your Ethernet adapter blinks, right? That it established a signal, layer 1. So the time that you open up a website, you actually going through all these 7 layers. So they built this model to make sure that all systems, Mac, Apple, right, Windows, Android, all of the systems have established communication using the model, okay? Now, if you're doing it wirelessly, that's through the airwave, right? 1 bit at a time, right? So anytime that your system sends and receives bits, that's layer 1, okay? Now, layer 2, this is when it's linking. So data link established here. And so it needs to see itself as an entity inside that part of the network, right? We're not talking about leaving the network yet. So this is a way that we can format messages into what's called data frame. And what it does is going to add the header information, and this layer mostly use the physical address, right? The MAC address to determine which system that is, right? And it's able to link with other systems. So this is a way that it can establish, communicate, and the switch operates at this layer, okay? So your data is linked and transmitted at layer 2. Now, the third layer is for network. This is when IP addresses is used and routing. So when you route and the system detects IP addresses, that's for network, okay? So if they ask you which layer of the OSI layer is the router, you know that's layer 3. Which layer is used for data link or the switch? Layer 2. Now, some switch operates at the higher layer. So basically, it's all in one device. It's a router and a switch in one. So you often see there might be layer 4 or layer 5 switch. So it's able to transport, establish session, and route. Okay. So voice over IP switch often is a layer 4. So in layer 4, your data is then being transported for services. Okay. Meaning that it goes from system A to system B in a remote network, right? After it gets routed. So when you're opening up your browser, Chrome or Edge, and you type in a URL, you're actually going through all of these layers and you're using your browser, which is at application layer. At the application layer, it actually gives you the website that you see, okay, here. But before that, it needs to make sure that the data is then formatted and translated from HTML code to what you see as a website. Okay, so when you're using your computer, right, when you visit a website like HTTPS, right, canvas.com or whatever, you going through the 7 layers from communication at signal one, and then routing from your network to the next, transfer that to the domain that you're visiting, and it established the communication, right, with the systems after it has reached that system, which is transport. Okay, so I'm gonna touch on these modes: simplex, half duplex, and full duplex. This is strictly for communication purposes. Simplex is one-way communication. It can only send or receive. Some system only does that, right? Half duplex, right? So full duplex is that it sends or it sends and receives both ways. Half duplex is one or the other. Okay, so if I have a simplex, my system can only send, right? But a half duplex it can send or receive. But a full duplex, it does both. Most of your communication system like would have full duplex, right? And we see this with communication line in media. Some media is able to, we can establish as full duplex. Some media we would only establish that for simplex or half duplex. And we'll come back to this later on as well. Okay, let's go through and answer some questions. But so my trick for you, so I always come up with like funny acronyms stuff so I can remember because it helps me, right? So P stands for people, D stands for don't, right? The way I say my OSI layer, people don't need to see purple alligator, right? Physical data link network and so on. So you can come up with a way that you can quickly remember, right, each of the letter for the OSI layer so that way you remember the all 7. Network Plus will ask you the OSI model along with TCP IP model, right? Same thing with CCNA or other network certification. So people don't need to see purple alligator. That's how I remember my OSI layer. Okay. So which OSI layer sends and receives bits? We know that's layer 1 at the cable level. Question 8. Device IP addressing is established in which OSI layer? Layer 3. IP address is used for routing. And IP is a connectionless protocol, right? It relies on TCP to connect. So TCP, it has to establish a connection before it gives you the actual data that it reassembled. Which OSI layer is responsible for code translation or code formatting? That's presentation. This is how it converts your HTML before it gives you at the next layer, which is application. So you can see, right, a button, a login screen, right, some text. So presentation puts everything together. So it takes the coded data and interpret it. And lastly, layer 7, which is application. It is a way that we can interface with the programs or the system. As the name, right? You know, application. So a browser is an application, right? Now, when you're using a web app, so when I say web app, that's like visiting a website and using its functionality. Like you click on a menu. If I go to my credit card, right, account, I go to the website like visa.com or citibank.com. and I would log in, so I'm technically using its web app through the browser, right? So we would go through all the 7 layers, and then sometimes you would go back and forth on the top 3 layers. Okay, like when I authenticate, it establishes the session. So that way it's secure, it's securing my data. And it's presenting to me what I click. So I would interface with the application. So if I click the menu and I would select pay bill, right? It would load the page again. So you would go through some of the top layers again, because it's already been communicated with citibank.com, etc. Question. Okay. I will move to the next one, right? So all the 7 of the OSI layers: physical data link, network, transport, session, presentation, and application. So know each of the purpose for each of the layer in the OSI layer, right? Now, the industry would refer to this model as a standard beginning model, but there is another model called TCP/IP model, right? So basically, they take the 7 layers and they break it down to fewer layers, like 4 or 3. So that way it is easier to remember, but the functionality is the same. You're gonna have to establish bit by bit signal communication all the way to the interface with your system. Okay, so I want to show you where that is in the notes. So we see the OSI information here, right? It talks about the benefits. So if the reason why they built this, so that way, if you buy products with different brand, it works the same way. Okay. Like if I buy a motherboard that has a network adapter that's integrated to build my gaming computer, that network adapter works the same way as the next network adapter that I buy, or the next one, right? It is a way to really standardize, because if you don't, what you're gonna have is you're gonna have a mix of things, and things don't work appropriately. So it's an agreement for all the vendor to kind of, work with this model to make sure that their device, their components works the same way. Give you the same output, right, for communication. And then you have the picture and it tells you some of the details. So when you encrypt data that's in presentation, or when you compress, right, some data is transmitted in a compressed format for the purpose that's presentation. Okay. When you are printing, that's part of application. When you're using a database, that's part of application. So you can refer to this image if you want a little bit more details on the application for each of the layer. Okay, so let's talk about SYNAC, because in a future lab, you are going to use a network sniffer to be able to see which system sends, right? Which system receives. And this is part of network monitoring, and it's also part of security, right? In security, we always say that, monitor your network, look at your traffic, who's coming in, who's coming out, which system sends, which system receives. If you're using TCP protocol, right? For example, if I visit a website, I type in mywebsite.com, right? My system would communicate, it's going to send a signal through the network, right? Trying to reach that domain and that web server. But before it really gives you the content of that website, there are a few things that that's happening in the back. First, it needs to synchronize with that system, hence the name SYN. Okay. Now, in ethical hacking class or in future classes, if you take security classes, they talk about SYN attacks, right? And it capitalized on this. So first, I need to synchronize my system, and system A and system B needs to synchronize, okay, to communicate. So it's gonna say, system A is gonna say, hey, I'm connecting to you, system B. And system B, at this point, gonna acknowledge, it says, okay, let's connect. So it sends an act confirmation back. Next, after it's already synchronized, it's gonna say, now I'm sending, right? So system A is gonna acknowledge that it's sending, or it's connected, right? And it's sending. So the connection is established here. And then once it does the acknowledgement here, then data transfer. This is why TCP takes longer. UDP, there's none of that. UDP is like, oh, I'm just sending. If it gets there, if not, oh well, right? If it gets there 5 minutes later, okay, doesn't matter. TCP, it has to have synchronized acknowledgement, right? So SYN act, and then at the end, when you look at the network monitor or the cipher, it's gonna tell you finished, it's done. Data has transferred, it's completed. Okay? So now the attacker, what they can do is depending on the approach and what the purpose of the attack. So if they want to capitalize on this, what they will do is they would either doing the man in the middle, where they would say, okay, I'm going to impersonate that system B, and I'm going to send the acknowledgement back so I can intervene and get your data. Okay. So there are multiple approaches in how they want to attack, and you would see that with some form of attack, and normally known as a SYN attack. Okay. And they can do that to do buffer overflow and other things. So if they want to flood your network, right, they would try to establish also this. Question. So I don't want to just to teach you and say, oh, remember these things. I wanted you to kind of draw like the correlation, like why am I learning this, right? In the big picture, ultimately, everybody in security, our job is to make sure that we prevent attack, right? Or we slow it down at least, so or seize it and stop it. So you know, you have to know what's happening in the back to prevent it. Question. Okay, so the next part talks about connection and connection-less oriented communication. So the two difference for question 12, it says a connection-oriented session. Why do hosts establish connection parameters? And we just talked about like how there's acknowledgement between two systems, right? Because in order to connect, there has to be an agreement, an acceptance, so that way the data can sync. So when you're sending data or data transfer, ultimately it's a form of agreement in syncing data across the systems, right? So it's a way that we use rules, which is protocols, to be able to have an agreement between the systems, so that way the data can synchronize. So when you are downloading, right, a song, right, that's a form of data synchronization of your system and where you're downloading from, ultimately. Now, some protocols are connection-less oriented, then it doesn't really have a true agreement, right, on if or when the data would synchronize, right? Like we talked about UDP. UDP, it might arrive later or sooner, there's no true agreement on when it should be ready to synchronize compared to some speed. Okay. Then we need to talk about flow control, right? Flow control is important, especially for network administration and management purposes. We want to make sure that the receiver, right, sends the appropriate amount of data. You don't want things to flood across the network. It's like, you know how if there are many cars going on the freeway, you're gonna have congestion, right? And you don't want that to happen on your network where everybody is on the network at a certain time and everybody slows down. You want to make sure that the system have appropriate. So we want to govern the amount of data that's sent. We don't want to send too much data or too few data, right? So it needs to really chunking up the data so that way it can flow. Now, your computer, when it receives information, you know that it puts it in RAM. You know that, right? Hence the term buffer overflow. Okay. So your buffer is basically a storage area where it stores temporary information, which is RAM. Server has RAM, your PC has RAM. So when it sends and receives information, all your connection information is actually in RAM. Your router has RAM, your switch, your managed switch has RAM. It is a way that it can track, right, what is sent, when it's sent, who sends it. It temporarily stores that and it stores it into the buffer. Now, if you give it too much, if you overwhelms it, if you dump a lot of data on it, it's gonna have an overflow. It exceeds the storage and your system halts. Okay, it's a simple concept. It's been like this for many, many decades. So when you do denial of service attack, okay, I should say you do. When you see denial of service attack, ethical hacking suits, they do, right? It's a form of buffer overflow. You just dump a lot of data to it, a lot of requests. You keep sending and it keeps putting it on RAM until it reached the limit of the RAM and it's like, doesn't know what to do. You know how when a person is super busy and you ask that person many questions and that person cannot respond anymore because they don't know which question you're asking at this point, right? That's buffer overflow, right? So when you put a lot of data to the buffer, you can stop it from working, right? So from an attacker standpoint, that's what's happening. So what you want to do is you want to regulate this, right? A lot of the technology and communication now, we do have a way to configure and regulating this, right? It's built with that. So our connection is appropriately sending and receiving data from and to systems. Okay, so we talked about a switch. The switch operates, your simple switch. I'm not talking about the advanced layer 4 or 5 switch, layer 2 switch. So if a switch, we talked about managed or unmanaged switch last week, right? An unmanaged switch would operate at layer 2. Sometimes a managed switch also only used in layer 2, right? So we would use that to connect system it across the network. So data link. It's a way that we frame our data, right? Give it a header, and it would be able to locate which system from the MAC address. So if I send data from this system to this system, what the switch does is it keeps a record of it. System A has a MAC address, this, right? System B has another address. So if I keep sending back and forth continuously, it just goes to the table, which is stored on RAM, right? To that way it can quickly, you know how it's like having cookies on your computer. So when you reload the website, it's quick. It's like that, right? So all system, router has a table, switch has a table. It keeps a record of it so that way it can quickly track, right, who's sending and who, so that way it doesn't have to reestablish communication. And then if it stops sending, it eventually goes stale, right? And then eventually it will flush that off the table. Okay. So we would talk about flow control. You can go to page 10, right? And it gives you the procedure, the step. and then some image. And then it goes into your connectionless communication, like we talked about UDP. Okay, I want to touch on data encapsulation. I think I talked a little bit about that the first week. So when you transmit data, we all know that everything is in binary, right? Okay, 0 and 1s, that's what the computer sees and that's what it stores, right? The text that you see, that's just for us, okay? The human context is what we see through the application. So when you are texting your friend, okay, you are typing in an app. Let's say that I'm using Google Message to text my friend. So it is an application that I'm using, but ultimately your computer takes that data, right? And it encapsulates it. Basically, it does the conversion. So that way, when it transmits my text from my device to my friend device, it's in binary, it's in packets, right? So your data transmit across the network in packets, and raw data is, it could be in chunks. So you don't really send everything in its entirety. That just takes too long because we have large data, right? We can have small or large data. So it's varied. And so now when it gets to the destination system, it decapsulates so that way it can convert it back into what you see as format for human context. And the same thing with making phone calls, right? We use voice over IP networks. So when you call, your voice is in analog, it converts that into digital, which is in 0 and 1s, and it transmits that as packets when it gets to whoever's receiving the phone call. It decapsulates that and it converts from digital to analog so that way you can hear people. Or if you're doing like FaceTime, you can see and hear them. Okay, so in the back, this is what it looks like. You can see all the layers here, right? So if I'm using my Android device or my iPhone, that's wireless, okay? Not wired, but it's still in bits. Then when you do so it needs to give it a header so that way it knows like where to send it to. So especially for the data, then when it gets to the network, this is when it starts routing into T-Mobile, Verizon, AT&T, whoever that you're using across their network. And then it transports, so it's gonna try to get to the destination system. Once it gets there, right, it's gonna make sure that all the data is then presented, establish the communication and then presented. And this is what you see in text or voice or data or website. Okay, so read a little bit more about our frame, what a frame is at layer 2. Okay. And what that looks like. So when we're using protocol analyzer, we're going to come back to this. So you can see it at different layers through the applications. And then it talks about the packets here. Okay. Now, sometime you would hear people say that, oh, I can impersonate or modify or stuff a packet. Sure, they can modify the content of the packet if your communication is not secure. It's a way that they can, change your data. They can also change the destination of your data by modifying the packet. You don't want that to happen, but it happens a lot in the wireless network, especially public Wi-Fi, right? And there are tools to be able to do that as well. So the industry, you see that there's software that they use to be able to modify. So basically, they just modify the content of how your data is transmitted across. Okay. Okay. So what type of devices operate at the physical layer of the OSI model? Your network adapter. So network interface card. And that could be also your wireless adapter, your cable, like an Ethernet cable or coaxial. Your transceiver, repeaters, a hub. A hub is different than a switch in that a hub it's like it takes the data and it just repeats that throughout the network. It's just retransmitted. It's not smart enough to detect error, so if it doesn't get to the destination, it doesn't know. And hub can also be flooded very quick. When you do this part, make sure you so press Control C to text. You have to copy the whole entire line. Yeah, because if it's doing this, it's not breaking your image into the appropriate file for the forensic part. Yeah, so press Control C. So click on your virtual machine, press Control C to cancel the process. You might have to do it a couple of times and then repeat that step with the entire command. Okay. Now for the layer 3, we know that the routers are functioning at layer 3. So your data is ultimately wrapped with the rules, with the protocols, right? For each of the layer, and each of the layer has specific protocol. So if it needs to route, right, it needs to use the routable protocol. So if your data needs to get outside the network, then it needs to route. Like with the HTTP does that. It has to route, right? It has to go to the external network for the domain. So your data is combined with the protocol information. And the way we format the packets, it's standard. So that way, it's kind of like, you know, how you go to the post office, they make you use a certain size box with a certain label, etc. It's like that in network, right? You have to have a packet, there's certain size of your data that can fit because of flow control, because we don't want too much, right? And then it needs to know like which device is supposed to receive it. So the protocols job. Almost there. I know it's kind of lengthy in this class, but I hope that you can have a better understanding, right, of your system and when you use things. Okay, let's move 17 down a little. Okay, so the next part in the notes, as I pointed out, it talks about frame, right? Frame is particular to layer 2. So a frame is basically a protocol data unit for data link layer or layer 2. It consists of a group of bits that would synchronize. And when we say packet payload, that's data, okay? And so that way it can check the sequence. So your data, when it breaks it up, it might be out of order, okay? Like I said, the bicycle in pieces, it's going to be out of order. We want to make sure that there's sequence in the data so that way it makes sense when it puts it back together. So when it gets to the destination, when it goes back to the layer 2, it checks the sequence of your data and also the size of your data. And this is part of the encapsulation, right? You want, when you make a phone call, you want to hear the correct information, the voice, the correct data, right? Imagine if you get gibberish, right? When it cannot encapsulate the correct data that was transmitted, then we don't have appropriate or successful communication. So each frame is then separated with a gap. So that way, again, we want to really think about how we would break this up so we have the right flow, we have control of how the data is transmitted, right? So when you're looking at what kind of data that is, the size of the data, it really comes back to the frame. It's a way that it structure your data into a format, so it can then eventually puts it into a packets at layer 3, right? So frame and then packet. So it preps it for the packets so that way it can send it to the other networks. Now, what if I don't send it to another network? What if I send it from one system to the next? Then it would then function at layer 2. Okay, that brings us to the next question. So then what is a packet? So packet is then used to transport your data from one network to the next. Inside a network, we use frame. Okay, that's a switch use. The router uses the packet. So it's like packaging, like at home, if you need to give someone like maybe a toy, right? You just hand it to them, right? But when you need to send someone a toy, then you need to put it into a box, put a label on it, pay for the shipping. So basically a packet is a way that we can package the data so we can send it from one network to the next network. Okay. Because when they receives it at the destination network, right? It's then gonna go through the layer again, and it's gonna go through and also break it back into the frame so that way the data is received in its entirety. And with that, the packet is always going to be associated with IP because IP is used to get from one, it's an address, right? It's like, how are they going to deliver the package to your home, right? That you have shipped. Well, home address. So IP is a way that we can get to the destination system, the packets to the right system that's receiving it. And it says that which are carried on one or more Ethernet frames. So in the Ethernet frames, so ultimately this is 802.3, and that is going to be able to route your packets to the receiving system. Any question? I know it's a lot of technical information, right? You should go back and think about each of the concepts because without understanding thorough networking, right, you're gonna struggle in the security area, right? Because you have to really understand like the functionality of the communication system because that's where a lot of things are happening. Like man in the middle attack, right? Denial of service attack, distributed denial of service attacks. Okay, so we talked about the standards last week, but when you see Ethernet, that's always going to be IEEE 802.3 without the extension, right? We touched on a little bit of this last week. So make sure we know 802.3 is for Ethernet. And then for wireless, that will be 802.11. I'm sure some of you know this well, right? But, right, the legacy, this is old. Which wireless 802.11 standards has transfer rate of 11 megabit per second? You look at this and you laugh, you're like, what? That's really slow, right? So years ago, that was really, the technology. 802.11b, the transfer rate of that will be 11 megabit per second. On AC now is much faster if you're using 5G, right? So wireless has two breakdown for frequency, right? When you say 5G, that's 1, right? Gigahertz is 5G, 5 gigahertz. So when you scale it hertz, you know that it's frequency. Now, most of your devices, your smart TV, your smart refrigerator, your smart washer, Some of them are integrated with 5G if they're very new, right? If they've been produced a while back, most of them are at 2.4 gigahertz. Okay, so most of your IoT devices operates at 2.4 gigahertz. As I mentioned last time, and I'm going to repeat it, we'll come back to the wireless in another unit. The lower the frequency, the longer the distance span. Okay, this is why most access points in CAN or in a lot of the local area network is at 2.4 gigahertz because it needs to reach the people who are walking across campus, right? And then if you use 5G, you have higher frequency for data transfer faster, but you have shorter distance span. Okay. So how do they get 5G across 5G, right? You hear T-Mobile get our 5G, right? Get our 5G internet service provider at home. Well, all I have to do is amplify and repeat, right? So the more towers, the more repeaters I put throughout, I can continue that signal across the frequency. Okay, understand? So we'll come back to wireless. But 11B is only at 11 megabit per second. And then they came out with another standard that has higher frequency. Now, some of them are compatible with one another, some of them are not. So G came after B, and this standard is right before the AC. So 802.11G, the throughput for that, the rate is 54 megabit per second. And that was pretty fast. The A was actually at this range, and so, but there was some incompatibility, and now they integrated new. So they're about to release a new one pretty soon too. So lastly, right, 802.11G. So why do you need to know about these legacy technology, right? It's important to really see like where we came from, and don't be surprised somewhere in the world you might end up landing in a job where they use a bunch of old stuff, and you might have that, right? Most people integrated for AC, but doesn't mean everybody is. You might have like old archive systems. So for example, schools, they have to back up things from like 1980s or whenever they opened, right? And those computers are old, and they might not integrate it into a virtual machine or a cloud system in it. So they might have an old system from 80s that's running, and they have the file. So in the case that someone came back and said, I graduated in 1982, can you pull my record? Well, you have to go in there and have that, right? And these systems, because of the hardware, they're connected with older network components, right? They don't have Ethernet cable. They might have like, so you're gonna see some of that, and don't be surprised. So we have to kind of know old stuff and new stuff, and that's important. Okay. Yeah.
Who's the project standard?
IEEE, which consists of industry, researchers, scientists, so that's global, right? And they meet and they discuss, so they're a researcher that focus and university professors and some universities like Berkeley and Georgia Tech, they participate in developing or, so you see some division of the. When I was at Georgia Tech, I walked through the division where they focus on like new network technology research. And you do see that they have development R&D in that area. And then when they decide on a certain standard, so that means that they agree, right? So they have to vote on it and go through the process. But yeah, so that's standardized for the world. And then you do see some stuff that is only used in certain region. I think because of the regulation for health purposes, right? You probably hear about stuff like we are different in bandwidth compared to like Asia or Europe, only because our regulations for North America is restricted. We're more concerned with like, like what type of frequency that we're allowed and we're not allowed to use, because radio. And so you do see some of that regulated. Okay. All right, any other questions? Okay, so what we're gonna do is, I'm gonna stop the recording. We're gonna take a little break. When we come back, we'll take attendance. And then we will work on the cable, so I'll talk about that when you come back. So let's take like a 7-10 minutes break. You should have enough time to do your cable after this.